Welcome back. So before we get started today, I wanted to let you know I'm going to make a slight change to the slides here. So previously we've been doing the problem on one slide, and then the next slide there's kind of a written out description of how to solve the problem. But I haven't really been paying too much attention to that. I've been sort of just solving them on screen. So I'm going to skip creating that second slide because I haven't been using it much anyways, and I think it's better to just solve it on screen. And it's faster for me to make these slides and continue this pace of one lesson per day if I skip that slide. So anyways, if you don't like that new format, let me know and I can see if we can come up with some compromise. But with that out of the way, we'll get started here on 2.4, negative exponents. Now this is a long lesson. There's a lot of problems. So try to stick with me, take breaks if you need it, but we'll go ahead and jump into it. So this first problem here is kind of like how we started the 0 as an exponent, where you have this sort of pattern recognition and fill in the blanks. So go ahead and pause this and see if you can come up with the answer for this one. All right, so if you noticed, we have the same pattern we did in the last lesson, and that is dividing each way down. So these are powers of 3, so each step down we're dividing by 3. And we know that because 3 cubed would be 3 times 3, and 3 squared would be 3 times 3. Oh, my pen is a little bit too sensitive right now, it's okay. 3 times 3. And so you know the difference. If we go up here, we just have this times 3. So going the other way, we have this divided by 3 to go down. So 27 divided by 3 would be 9, then divide by 3, divide by 3. So continuing that same pattern, you would think that this one would be 1 divided by 3. And 1 divided by 3, well, we know that division is the same as multiplying the reciprocal. So that would be 1 times the reciprocal of 3 would be 1/3. So that would equal 1/3. All right, so that one is 1/3. And now 3 to the negative 2 would be 1/3 divided by 3 again. So again, we'd have 1/3. Division, the same thing as multiplying the reciprocal. So dividing by 3 is the same thing as multiplying 1/3. If you know how to multiply your fractions, then this would be 1/9. Now, if you're following this pattern, 1 to 1/3 to 1/9, you might think that this next one would be 1/27, and you would be right. So what is the connection between 3 cubed and your predicted value for 3 to the negative 3rd? Well, 3 to the negative 3rd is 1/27, and 3 cubed is 27. So 3 to the negative 3rd is just the reciprocal of 3 to the 3rd. And same thing with these other ones. Look, 3 to the negative 2 is the reciprocal of 3 squared. And that's always going to hold true. All right, give this one a shot. So this is one is saying, is showing us what we talked about a couple lessons ago, where we have this exponent rule, where we know that if we have division of exponents, so if we have the same base, let's say 4 to the 4 divided by 4 squared, if we have division with the same base, we can subtract these exponents. So this would be the same thing as 4 to the 4 minus 2, which would be 4 squared, or 16. Right? So that's what this is saying. We can also go backwards if we wanted to do that. And so what this is asking is, now give this a shot where this subtraction would create a negative number, and see if that still works. So go ahead and see if you can come up with an example that would create a negative number, and see if you can come up with the answer for that once it becomes a negative exponent. All right, so one example that we can use is if this first one is 0. So if we have, let's say we have 4 to the 0 divided by 4, I don't know, squared. All right, and that would be, well, we know 4 to the 0 is going to be 1. And we know division is the same thing as multiplying the reciprocal. So let's say times 1/4 squared. Well, 1 times anything, it just gives us the original number back. So we have 1/4 squared. And that's similar to our last problem here, where we found that the the negative exponents were just the reciprocal of the positive exponents. So 3 squared is, 3 to the negative 2 is the reciprocal of 3 squared. And now we can see exactly why that is. So if we have 4 to the 0 times the reciprocal of 4 squared, then we get that reciprocal of 4 squared when the exponent is negative. Because this would have been 4 to the negative 2. This would have created, because 0 minus 2 would be negative 2. So 4 to the negative 2 ends up becoming the reciprocal of 4 squared. And here we have this rule that says just that. So when you have a negative exponent, you get the reciprocal of the positive exponent. All right, and there's more explanation in this video here. Like always, I'll be posting the video links down in the description below. I recommend you go watch all of these just for additional information. All right, go ahead and give these 5 expressions a shot. Go ahead and pause this and try these out. All right, so for this first one, we have 1 to the negative 5th. So we're getting the hang of this now. We know that, as we learned here, I'll write it out on this screen. We have a to the negative n is equal to the reciprocal of a to the n. So a to the n equals the reciprocal 1 over a to the n. This should have been negative. A to the negative n equals the reciprocal of a to the n. All right, so with that written out there, so let's try this first one. So 1 to the negative 5 would equal 1 to the 1 to the 5th. And 1 to the 5th is going to be 1 times 1 times 1 times 1 times 1, and that's going to give us 1. So 1 over 1 would, of course, be 1. All right, so now 10 to the negative 4. So that's going to give us the reciprocal of 10 to the 4th. Let me see if I can fix the sensitivity on this pen real quick so I'm not writing all over the place. We'll see if that helps out. All right, so didn't at all. So I'll just have to be careful. All right, so 10 to the 4th would be, so 1 over, 10 to the 4th would be 1 and 4 zeros. 1, 2, 3, 4, 1 over 10,000. All right, so this one we'll write over here. 2 to the negative 3 would be 1 over 2 cubed. And that's going to be 1 over 8. 2 times 2 is 4, times 2 is 8. And then this one right here, 56 times, now I have the reciprocal of 2 to the 3rd. 2 to the 3rd, which we already know is 1 over 8. So it'll be 56 times 1 over 8. And look what we have here. We have multiplying a reciprocal. Well, we know that's the same thing as division. Multiplying the reciprocal is the same thing as division. So we can go ahead and convert this to 56 divided by 8. And that's going to give us 7. All right, this last one here, 56 divided by 1 over 2 to the 3rd, which is going to be 56 divided by 1 over 8. Okay, and then so we can convert this division to multiplication. So we have 56 times, what's the reciprocal of 1/8? Well, the reciprocal of a reciprocal is back to the original number, right? So if we have the number 8 and we want to find the reciprocal to that, it's going to be 1/8. And the reciprocal of a reciprocal is back to 8 again. So the reciprocal of 1/8 is 8. So 56 times 8, let's see what that is. 56 times 8, we have 48, 6 times 8, and 8 times 50 would be 400, and that would be 448. All right, so a few more, give these a shot. Go ahead and pause this and give these a shot. All right, so this first one here, we have 3 to the 5th times the reciprocal of 3 to the 5th. Well, we know that's, if you remember our identity lesson, that's exactly the example that's shown here. When you have the same number here as you have as the bottom of the fraction here for a reciprocal, that's just going to be 1. Okay, so we have 3 to the 6th times 1 over 3 to the 4th. Okay, so if we, let's go ahead and change this. This is multiplying a reciprocal, which is the same thing as division, right? So we'll have 3 to the 6th divided by 3 to the 4th. And if we know our same base division, then this would be 3 to the 6 minus 4, which would be 3 squared, which is equal to 9. All right. So if you struggled with any of these, feel free to pause it in between expressions. So if you didn't get that one, but now you you understand, go ahead and give these last two a shot. But I'll go ahead and solve these now. All right, 3 to the negative 1 would be the reciprocal of 3 to the 1. So 1 over 3 to the 1, which is really just 1/3, right? Times 1 over 3 squared. So this can be 1/3 times 1 over 9. 3 times 3 is 9. All right, so we have multiplying a reciprocal, which is the same thing as division. So let's convert that to division. Actually, you know what? That's not going to really help us to do division, will it? Let's just do fraction multiplication. I think that'll be a little bit easier than doing 1/3 divided by 9. So that's going to end up being 1 over 27. Another way that you could have done this is, so back to this step right here. So I'll write this step over here. We had 1 over 3. Actually, yeah, I'll keep the exponent the same. So we have 1/3 times 1 over 3 squared, right? So another way that you could have done this is 1 over, combine them, 3 times 3 squared. You could even say 3 to the 1. And then, so now you have multiplication of exponents with the same base. So then that would become 1 over, you can do 1 plus 2, be 3 cubed. And you know that that is going to be 1 over 27. You get the same answer. All right, so then this last one here, we have 3 to the 15th times the reciprocal of 3 to the 5th times the reciprocal of 3 to the 4th times the reciprocal of 3 to the 3rd. Okay, so this one might look a little bit scary, but it's really not that bad. So let's go ahead and combine these. So we have 3 to the 15. Don't want to forget about that. Times 1 over. Let's do 3 to the 5th times 3 to the 4th times 3 to the 3rd. Well, we can see multiplication with the same base. We would keep our 3 to the 15, can't forget about that, times 1 over, let's see, 5 plus 4 is 9, plus 3 is 12, so we have 3 to the 12. All right, so now we could convert this to division. This is multiplying by a reciprocal, so we can convert this down here. Let's do 3 to the 15 divided by 3 to the 12th. And now we have some subtraction. We got the same base, so we can subtract these exponents. So now we have 3 to the 3rd. And that is going to give us 3 times 3 is 9, times 3 is 27. Hopefully you got that one. I know that one was a little bit more involved, but if you really just write it out and take it step by step, hopefully it's not too bad. All right, on to the next one. All right, give these a shot. Go ahead and pause and give these expressions a shot. All right, so first one here, evaluate 1 over 2 to the negative 3rd. All right, so this is it's gonna be a reciprocal of a reciprocal, right? So we write this out, we're gonna have 1 over, well, 2 to the negative 3rd is going to be 1 over 2 to the 3rd. So this is gonna end up being 1 divided by 1 over 2 to the 3rd. And so this is a reciprocal of a reciprocal. And you know that the reciprocal of a reciprocal is going to give us back our original number. So we know this is going to be 2/3, 2 to the 3rd. But if you write it out like this, 1 divided by 1 over 2 to the 3rd, we can convert that to multiplication. That becomes 1 times 2 to the 3rd. And that becomes 2 to the 3rd, or 8. All right, so the same thing here. 1 over, you can say 25. No, it's going to be 5 squared, it's 25. And reciprocal of reciprocal, you know it's going to be 25. So, assuming that a is non-zero, because a is in the denominator, so we can't have a be 0. How are 1 over the reciprocal of a to the negative n and a to the n related? Well, they're the same thing, right? Reciprocal of a reciprocal is going to be the original number. All right, so similar here. Go ahead and give these a shot. All right, so this first one, 1/2 to the negative 1. Well, so one thing that we've been doing all along is that when you have an exponent applied to a fraction, we've only been applying it to the denominator, which is kind of a, I don't know, skipping a step, but I'll show you the reason real quick. So this textbook often only applies the exponent to the denominator because we've only been working with fractions with 1 in the numerator. So it's worked out, but I just wanted to make a note of that because normally with exponents you would apply the exponent to the numerator and the denominator. It just happens to work out that the numerator has been 1. So if you have 1/2, oh, I just wrote 1/3. If we have 1/2 taken to some exponent, we'll say negative 1 because that's our example here. You would apply that to both the numerator and the denominator. So we would do 1 to the negative 1 and 2 to the negative 1. So let's do 1 to the negative 1 first. So 1 to the negative 1 would be 1 over 1 to the 1, right? The reciprocal of 1 to the 1, which would end up being 1 over 1, which would equal 1. So it ends up being the same thing. So that's why we don't really worry about applying exponents to a 1, because it doesn't change the 1. Even if it was 1 to the negative 2, then it would just be 1 over 1 squared, and 1 squared is also 1. So it's always going to be 1. So I do want to make a note of that because it's not that we're not applying the exponents to the numerator. We are. It just happens to be that it comes out to be 1 anyways. So that's why that step, if you look in the book, is often skipped, and we only end up applying the exponent to the denominator. So with that said, let's go ahead and evaluate these. So this is going to become 1 over 2 to the negative 1. And that is going to be 1 over the reciprocal of 2 to the 1. So 1 over 2 to the 1, which is just 2. Sorry about the sloppy handwriting. This pen is a little bit too sensitive. And the reciprocal of a reciprocal is going to be this number here. 2 to the 1 is just 2. All right, so this next one here, we have 1 over 2 to the negative 2, right? The exponent gets applied to the denominator. And this is going to be 1 over 2 squared. This handwriting is getting worse and worse. Let me just try to use my mouse, see if that's a little bit better. And reciprocal of reciprocal would be 2 squared, which would equal 4. So here, let me try to rewrite this real quick. So this is going to end up being 1 over 2 squared. All right. And then this third one here, same idea. It's going to be 1 over 2, and then the exponent gets applied to here, so 2 to the negative 3 is going to end up being 1 over the reciprocal of 2 to the third, so 2 to the third, and the reciprocal of a reciprocal, once again, would be 2 to the third, which would equal 8. All right, so if a is non-zero, then how are these two related? So if we know that this negative exponent is going to get applied to the denominator, then you know that's going to become the reciprocal of the reciprocal. So that's going to end up equaling a to the n. Again, there's a video here you can go and check out. All right, give these 5 expressions a shot. I think we're getting towards the end, so power through and let's make it through. All right, so let's see here. So the first one here, so let's do negative 3. So a negative sign, negation is it would follow the same step as multiplication in your order of operations, because a negation is the same thing as multiplying by -1. So with your order of operations, we would do the exponent first. So we still have to have the negation here. We're going to evaluate the exponent. It's going to be 3 to the -2. So 3 to the -2 is the same thing as 1 over 3 squared. So don't forget our negation. Negation is still going to be there. And this is going to be 1 over 9. All right, that's for the first one. So second one here. So now the negation is inside the parentheses. So now this exponent gets applied to the negative also. So this is going to be the reciprocal of -3 squared. Well, -3 squared would be -3 times -3, and a negative times a negative would be a positive, so this would be positive 1/9. All right, so now this one over here. Again, this negation is included in the parentheses here, so we'll do 1 over -2 cubed. All right, so what is -2 cubed? Well, we have -2 times -2 would be +4. +4 times -2 would be -8. So it would be -1 over 8. You see that, so the negative would have been in the denominator. So if you were to have written it like 1 over -8, that's fine. That is correct also, but generally when we have a negative sign in either the numerator or the denominator, we usually pull it outside the fraction and say the entire fraction is negative. All right, so then this next one here, we have 1 over -3 to the -2. So we have 1 over, well, negative exponent is just going to be the reciprocal. So 1 over -3 squared. So reciprocal of reciprocal, that's going to be -3 squared, which we know is going to be positive 9. Same thing here. Reciprocal of reciprocal, so we have 1 over -2 cubed. That's going to give us, reciprocal of reciprocal is going to be -2 cubed. And we know that -2 cubed, we just did it here, is going to be -8. Remember odd exponents, when applied to a negative number, is going to give us a negative. Even numbers applied to a negative number is going to give us positive numbers. All right, how is 2 to the -3 and 2 to the -1 to the negative? Let me try that again. 2 to the -1 to the 3 related. And let n be a positive integer. How are 2 and -n and 2 to the -1 to the n related? And then how is anything to the -n and a to the -1 to the n related? All right, so this one's pretty simple and straightforward. Hopefully you can just see if you remember your exponent rules, then if you remember when you raise a power to a power, you can multiply them. So our 3 rules we had were if we had a to the m times a to the n, then we could add these together, right? That would be a to the m plus n. That's for multiplication. If we have division, a to the m divided by a to the n, then we can subtract them. That would be a to the m minus n. And then if we have a power to a power, so if we have a to the m to the n, then we can multiply those. So that would be a to the m times n. And that's what we have right here. So we have -1 times 3 would give us -3. So those two are the same. So here, the same thing. We have -1 times n would be negative n. So those two would be the same. And same thing here, a to the negative n. And this one would be a to the negative 1 times n, which would also be negative n. So they're all three the same. Okay, let a and b be non-zero numbers. Explain why this is the case. All right, so let's go ahead and see if we can just work this out. So a to the negative 6 is going to be the reciprocal of a to the 6th times, remember when variables are just like touching like that, that means they're being multiplied. So times the reciprocal of b to the 6th. Well, we can combine these fractions here to be 1 over a to the 6th, b to the 6th. And if you have the same power, you can pull that out to look like 1 over ab to the 6th. This was a information tag a few slides ago. I think it was in the last section or 2 sections ago, where there's a rule where you can pull out the exponent if they're multiplied with the same exponent. This would apply to both of these variables. All right, so now that we have this, well, this is the reciprocal of ab to the 6th, so that would be the same thing as ab to the negative 6, which is what we have right there. Okay, express each of these as a power of 2. Let's go ahead and give this a shot. If you're not really sure how to start with these, I'll kind of get you started, and then you can go ahead and pause and see if you can try it out. So you can see that 4, you know that 4 is a power of 2, because 2 squared is 4. So if you know that, if you know 2 squared is the same thing as 4, you can go ahead and convert this to a power of 2. Give that a shot. We still can't figure that out. Don't worry. We'll go over it here in a second. So now that we know that 2 squared is the same thing as 4, we can go ahead and replace this 4 with 2 squared. So we'll just swap that out. So 2 squared instead of 4 to the 16th. All right, so we know we can, if you raise an exponent to an exponent, we can multiply that. It's gonna be the same thing as 2 to the 32nd. All right, so that's expressed as a power of 2. Now this next one right here, so we have negative 2 to the 34. Now this one is a bit tricky, but you might kick yourself when you find out what the answer is. So how do you express negative 2 as a power of 2? You can't really do it. You can't convert negative 2 to a power of 2, but we do know that if you raise a negative number to a positive exponent, it becomes positive, right? Negative 2, say negative 2 squared, for example, would be positive 4. So negative 2 squared actually is the same thing as 2 squared, right? And this is a negative exponent. So really, negative 2 to the 34 is the same thing as 2 to the 34. All right, and then 16 to the 8th. Well, 16 is a power of 2. We know 2 times 2, so 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th. 2 to the 4th would be 16. So we'll swap that out, and we'll say 2 to the 4th, which is, we know is the same as 16, to the 8th. And a power to a power rule is going to be 2 to the 32nd. Actually, the same as this one. All right, and where are we at here? So can I express these as a power of 2? All right, so 1/8. So we know 8 is a power of 2. So this would end up being 1 over, if you remember your powers of 2 for 8, that would be 2 to the 3rd, or 2 cubed. And this would end up being the same thing as 2 to the negative 3. And then we're going to raise that to the negative 11th power. That's what we're doing right here. And so we can multiply these together. And this would be 2 to the 33rd. That'd be positive because negative times a negative. All right. And this last one right here, 2 to the negative 4 times negative 8 would be the same thing. So negative 4 times negative 8 would be positive 32. So this would be 2 to the positive 32. Again, so this one is the same as this one and this one. All right, so now we can compare all those. Which of the following is the largest number of all the ones we just converted? So let's see. We have 2 to the 33rd, 2 to the 32nd, 2 to the 32nd, 2 to the 32nd, 2 to the 34th. So it looks like this one is the biggest. So negative 2. So negative 2 to the 34th, this one right here, would be the biggest of the 5. All right, so let x and y be non-zero numbers and simplify all this stuff. All right, so let's go ahead and let's use our commutative properties and our associative properties to get our x's and y's together. We know we can rearrange and reorder however we want. So let's go ahead and get the x's together. So let's do x to the 4th times x to the negative 1. Then our y's together. Let's do our positive 1 first. Again, we can do it any order we want. Y to the 5th times y to the negative 2nd. Well, you know, if we multiply exponents with the same base, then we can add them together. So 4 plus negative 1. Well, adding and negation is the same thing as subtraction. So that would become 4 minus 1. So that would be x cubed. And this one here, 5 plus negative 2 would be the same thing as 5 minus 2. So that would be y cubed. And there we go. And again, go ahead and check out that video. And we made it. We made it through negative exponents. So we also made it through chapter 2. That is the end of chapter 2. So go ahead and do your 2.4 exercises. There is a 2.5. It's a summary of the chapter. So go ahead and go through the summary of chapter 2. And then go ahead and give the chapter 2 review questions and challenge problems a shot and see if you can do those before moving on to chapter 3. And I will see you in chapter 3.